We will learn how to perform 2D analysis in ANSYS Workbench. We see different kind of components, mechanical components. Here you can see there is a thin sheet metal component, and then there is a very long beam, and then there is a cylindrical vessel. All these analysis for all these components, they can be performed with the exact geometries in 3D analysis. But when you go for a 3D analysis, the node count and the complexity in the simulation increases. So to make this computation effective and efficient, more efficient, we can perform this analysis as a 2D analysis. So for example, if in this sheet is thin, and in this component we can see that the sheet is thin, and the stress along the thickness direction would be very less. So we can assume a plane stress scenario in this case, and we can perform a 2D analysis with the plane stress assumption for this kind of component. Here the bar, like the beam, is very long, and the loading won't have a very high effect on the strain in the longitudinal direction. So in this case, if the strain is assumed negligible, this can be performed as a plane strain condition. And in this scenario, we can see that the stress and strain state at the angular direction won't change. So this will change in this direction, this will change the radial direction, but this won't change in the theta direction if it is a perfect cylinder. So or every cross section it is symmetry about an axis, then this kind of analysis can be performed as an axisymmetric analysis. So here you can see, like if the thickness is very small and the stresses in the z direction is assumed 0, then this can be done as a plane stress condition. If the thickness is very long as compared to the other 2 dimension, then this can be assumed as a plane strain condition. And if each cross section of this kind of object is symmetry about an axis, then this can be performed as axisymmetric analysis, where the stress and strain does not change with the theta. Okay, so now let's go to the ANSYS Workbench. Okay, now we have here 3 cells: plane stress, plane strain, and axisymmetric analysis. To perform any 2D analysis, first go to the geometry, and by default ANSYS Workbench have this analysis type as a 3D, so we should change it to 2D analysis. Okay, then import your geometry here. So either you can create open the space claim, and you can create the 2D surface geometry in XY plane. You have to ensure that this geometry is in XY plane. Okay, so you can create the geometry, and then you can open the mechanical. Once mechanical is open, go to the geometry, and for 2D behavior we need to change from here. For different analysis, for plane stress, plane strain, and axisymmetric, we need to change the 2D behavior on the geometry from here. Then you can go to the geometry, and for plane stress condition you need to assign the thickness. Okay, if you want to perform a strain scenario, for example here in this one the 2D behavior is set as plane strain, then in this one you don't have to assign the thickness, because in this case the thickness is assumed to be infinite long in the z direction. So you just need to assign the material. Similarly, in the axisymmetric analysis also, when you set the geometry as a axisymmetry, here also you don't have to assign the thickness, because it is assumed that the axis of symmetry is y direction. In this one, this y axis will be considered as the axis of symmetry, and this will be swept 360 degree. Okay, which we can see later in the visualization. Okay, now after setting the geometric behavior and the material property, we can go to connections and create the connections if required. So here we have only one body, so we don't have to assign any connection. Then we can go and mesh it. Okay, so for this one I have just given a global element size of 0.4 to mesh it. So this is how the mesh looks. Then you can go and assign the loads and boundary conditions. So we have fixed it from here and given a displacement in the other edge. Okay, so now let's see for this one. Yes, the same boundary condition. Okay, it is fixed here and given the displacement here. And then you can solve it. Okay, so now once you solve it in visualization, you can see we have displacement and the stress. And here in visualization you can see it in 3D. So when you are performing a plane stress and we have given the thickness of this geometry as 1 millimeter, we can see that in the mesh also and in the geometry. But this is just for visualization. Only the 2D analysis has been performed. The internal calculation is performed based on the 2D mesh. Okay, now when we go to the visualization of the plane strain, so similarly here also connection and mesh is generated, and the boundary condition fixed and displacement is applied. And when we visualize here, we only see the plane result in one plane only. We don't see thickness here, because in the plane strain the thickness is assumed as infinite, so it doesn't make any sense to see it in 3D. And also it is assumed that there won't be any change in the strain, so it's also not visible here. Okay, then we can go to the axisymmetric analysis. So similarly here also the connection and the mesh is generated, then fixed and the displacement is applied, and the displacement of same 1 mm is applied here also. Now here you can see it is a 2D result only, but if you want we can see it in 3D. So you can go to model, apply symmetry, then symmetry type in here 2D axisymmetry, and here you can see set the number of repeat for theta is 10. So if 37 we give, it will come as a whole circle at 360, but like for example let's make it 60, so we will be only seeing 60-degree sector. So now you can see the 60-degree sector we are seeing here. This is the deformation, this is the stress. You can see an animation for it. Let's see the animation. Yeah, so you can